What if I told you that your entire digital life, your money, your work, your entertainment, your home security, even your ability to communicate with loved ones, hangs by a thread so thin that a single technical hiccup can sever it completely? Most people assume the internet is this robust, distributed, resilient thing that can rote around damage. That's the legend we've been told since the early days of the web. But on October 20th, 2025, that comforting myth shattered into a million pieces when a problem affecting one company in one data center in Virginia managed to simultaneously cripple banking systems in London, disable video games in Tokyo, lock parents out of their children's location tracking apps, and render millions of smart doorbells as useful as decorative paperweights. This wasn't a cyber attack by hostile nations or a sophisticated hacking operation. This was something far more disturbing, a routine technical failure that exposed the shocking truth about how our digital infrastructure actually works and how terrifyingly vulnerable we all are. The lie we've been living. For decades, we've operated under a fundamental assumption: the internet is decentralized and resilient by design. The story we tell ourselves goes like this: the internet was built by the military to survive nuclear war, routing information around damage automatically, distributed across thousands of servers and networks so that no single failure could bring it down. That narrative is technically true for the internet's underlying protocols, but it's dangerously false for how the modern internet actually operates in practice. The reality is that massive portions of our digital infrastructure now run on just a handful of cloud platforms, with Amazon Web Services controlling roughly 32% of the entire global cloud market. Microsoft Azure holds about 23%, and Google Cloud captures approximately 11%. Together, these three companies control roughly 2/3 of the cloud infrastructure that powers the modern internet. And within AWS itself, the concentration is even more extreme. The U.S. East 1 region in Northern Virginia has become a de facto single point of failure for a staggering portion of online services. When something goes wrong there, the effects aren't contained to one region or even one country. They ripple globally within minutes. The 7-hour window into digital fragility. Let's reconstruct what actually happened during those 7 hours of chaos, because the timeline reveals something genuinely alarming about systemic dependencies most people never think about. The failure began deep within AWS infrastructure, with something called a DNS resolution failure affecting DynamoDB API endpoints. Here's why that matters in plain language. DynamoDB is a database service that stores and retrieves information for countless applications. DNS resolution is how computers find services on the network, like a phone book that translates names into addresses. When that phone book stops working for a critical database service, every application depending on that database immediately loses the ability to function. But the nightmare didn't stop with direct DynamoDB users. This is where modern cloud architecture becomes a house of cards built on a foundation of interdependencies. Services that authenticate users, verifying you are who you claim to be, often rely on DynamoDB to store authentication tokens and user credentials. When DynamoDB became unreachable, authentication failed across thousands of applications. Services that process payments often use DynamoDB to track transaction states and prevent double charging. When DynamoDB went dark, payment processing froze. Services that coordinate communication between different parts of applications, microservices architecture, frequently use DynamoDB to maintain state information. When DynamoDB became inaccessible, these services couldn't coordinate, and entire application ecosystems collapsed. The cascading nature of the failure meant that services which didn't directly use DynamoDB still failed because they depended on other services that did. It was like watching a controlled demolition where cutting specific support structures causes an entire building to collapse in on itself. Except this wasn't controlled, and the building was a significant fraction of the internet. The industries that went dark. Let's talk about specific casualties, because the breadth of affected services reveals just how concentrated our digital infrastructure has become. The gaming industry took a devastating hit. Fortnite, with its 650 million registered players, went completely offline. Roblox, which has 70 million daily active users, many of them children whose entire social lives happen on the platform, became inaccessible. Clash of Clans, Clash Royale, Rocket League, and Pokemon Go all failed simultaneously. The Epic Games Store, a major digital distribution platform for PC games, stopped functioning. This wasn't just entertainment disruption. For professional esports players and streamers, this was their livelihood evaporating for 7 hours. Social media and communication platforms experienced mass casualties. Snapchat received over 5,000 user reports within the first hour. Signal, the encrypted messaging app used by journalists, activists, and privacy-conscious individuals worldwide, went offline. Zoom, which hosts hundreds of thousands of business meetings and remote work sessions daily, experienced severe disruptions. Canva, used by millions of creators for graphic design work, became unusable. The financial sector meltdown was particularly alarming because it exposed vulnerabilities in critical monetary infrastructure. Coinbase, holding custody of billions of dollars in cryptocurrency for millions of users, went completely dark, meaning people couldn't access their digital assets during a period when cryptocurrency prices were fluctuating. Major UK banking institutions, including Lloyds Bank, Halifax, and Bank of Scotland, received thousands of customer complaints as online banking and card payment processing systems failed. People couldn't pay for groceries, couldn't access their account information, couldn't transfer money. Basic financial functions that we now take completely for granted simply stopped working. Enterprise productivity collapsed across sectors. Slack, used by millions of workers for business communication, experienced widespread outages. Smartsheet and Airtable, project management platforms used by enterprises for critical workflows, became inaccessible. Duolingo, with its 24 million daily active users trying to maintain language learning streaks, went offline. Even Wordle, the simple word game owned by the New York Times, failed, illustrating how even the simplest web services depend on complex cloud infrastructure. Perhaps most disturbing were the physical security implications. Ring doorbell systems, installed on millions of homes for security monitoring, stopped functioning, leaving properties unmonitored during those 7 hours. Life 360, a location tracking service used by millions of families to know where their children are, went dark. Imagine the panic of parents unable to locate their kids during an emergency. National rail transportation systems in the UK experienced disruptions affecting schedule information and ticketing systems. The $2 million per hour reality. Let's talk about the staggering financial devastation this caused, because the numbers are almost incomprehensible. Industry research from ITIC indicates that 90% of enterprises face downtime costs exceeding $300,000 per hour. For large enterprises with complex operations, that figure can easily reach $1 to $5 million per hour, with thousands of businesses affected and the outage lasting approximately 7 to 8 hours. We're looking at aggregate economic losses potentially exceeding several $billion globally. But those direct downtime costs are just the visible tip of an enormous iceberg. Consider the cascading economic effects. E-commerce transactions that were abandoned and never completed, revenue permanently lost, customers who experienced service failures and lost trust in brands, potentially switching to competitors, emergency IT response costs as companies scrambled to understand what was happening and attempt workarounds, productivity losses across millions of workers, unable to access collaboration tools and business systems, reputational damage to companies that appeared unreliable through no fault of their own, regulatory scrutiny and potential fines for financial institutions that failed to maintain operational resilience, opportunity costs from projects delayed and deadlines missed. For AWS itself, the incident threatens something potentially more valuable than immediate revenue: customer confidence. When companies realize their entire business can be taken offline by a single point of failure completely outside their control, they start seriously reconsidering their infrastructure strategies. The cloud computing market is worth over $500 billion annually and growing rapidly, but that growth depends fundamentally on trust that cloud providers can deliver reliable service. The pattern that proves this isn't random. Here's what should genuinely terrify anyone paying attention. This wasn't an isolated incident or unprecedented failure. This was the latest in a recurring pattern of catastrophic outages affecting the same region. December 2021 saw what's considered the worst AWS outage in history, approximately 7 hours of disruption caused by network device overloads and NAT gateway failures in US East 1. June 2023 brought elevated error rates affecting Lambda, IAM, SQS, EventBridge, and Amazon Connect, impacting major customers like the Boston Globe and New York's MTA. September 2021 delivered an 8-hour disruption from Amazon EBS I/O issues that cascaded through multiple database services. Notice the pattern? These aren't once-in-a-decade black swan events. These are recurring failures happening every 12 to 18 months, affecting the same critical infrastructure, causing similar cascading failures and impacting millions of users each time. This suggests something fundamentally problematic with how this infrastructure is architected and operated. The fact that the same region keeps experiencing catastrophic failures indicates that the concentration of services, the complexity of interdependencies, and the single point of failure architecture creates systemic risk that hasn't been adequately addressed. Why your business is more vulnerable than you think. Most business leaders and IT professionals are operating under dangerous misconceptions about their risk exposure. Many believe we have disaster recovery plans, so we're protected. But disaster recovery plans typically focus on recovering your own systems and data, not on the scenario where the entire underlying cloud platform becomes unavailable. We use multiple availability zones, so we're resilient, but availability zones within the same region often fail together during major incidents. As this outage demonstrated, AWS is too big to fail, and they have the best engineers. Size and engineering talent don't prevent failures, they just make the impact larger when failures occur. The uncomfortable truth is that most organizations have created invisible dependency chains they don't fully understand. Your application might run on AWS Lambda functions. Those functions might call APIs hosted on AWS API Gateway. Those APIs might authenticate using AWS Cognito. Cognito stores user data in DynamoDB. When DynamoDB's DNS resolution fails, your entire application stops working, even though you thought you were just using serverless functions. You can't see the dependency chain because it's hidden inside the cloud provider's infrastructure. The regulatory earthquake that's coming. Financial regulators around the world are waking up to cloud concentration risk, and the regulatory response will fundamentally reshape how companies architect their systems. The EU's Digital Operational Resilience Act, DORA, already requires financial institutions to demonstrate robust protections against ICT service disruptions and mandate specific measures for managing risks from third-party service providers. The Financial Stability Board has published reports identifying cloud concentration as a systemic risk to global financial stability. The UK's Prudential Regulation Authority now requires banks to demonstrate they can maintain operations even if their primary cloud provider experiences extended outages. Emerging regulatory requirements will likely mandate multi-cloud capabilities for critical infrastructure, require demonstrated ability to fail over between cloud providers within defined time windows, demand regular testing of disaster recovery procedures, including cross-cloud recovery, and impose significant penalties for operational resilience failures affecting customers. Companies that haven't started preparing for these requirements are setting themselves up for expensive, disruptive, forced architectural changes in the near future. What actually needs to change? The solution isn't abandoning cloud computing. That ship has sailed. Cloud infrastructure provides genuine benefits in scalability, cost efficiency, and innovation velocity. But we need fundamental changes in how we architect systems and manage risk. Organizations must stop treating cloud services as infinitely reliable and start designing for failure. This means implementing genuine multi-cloud strategies where critical workloads can fail over between AWS, Azure, and Google Cloud, building applications with graceful degradation so that when dependencies fail, the application continues functioning in reduced capacity mode rather than failing completely. Maintaining hybrid architectures where truly critical systems can fail back to on-premises infrastructure during cloud outages, implementing comprehensive circuit breakers and bulkheads that prevent cascading failures from propagating through entire systems. Cloud providers themselves need to address architectural concentration risks that create these single points of failure. The industry needs better standardization so that applications can more easily move between cloud providers without complete rewrites. And regulators need to develop frameworks that incentivize resilience without stifling innovation, a difficult balance but increasingly necessary as cloud infrastructure becomes truly critical to economic and social functioning. The wake-up call we're ignoring. The October 2025 AWS outage revealed the dirty secret hiding underneath our digital lives. We've traded the distributed resilience of the early internet for the concentrated efficiency of cloud platforms, and in doing so, we've created vulnerabilities that didn't exist before. We've built a digital civilization on a foundation with critical single points of failure, and we're only beginning to understand the implications. The next major outage, and there will be a next one, might last longer, affect more services, or hit during a more critical moment. The question isn't whether our cloud-dependent infrastructure will fail again. It's whether we'll start taking these vulnerabilities seriously before a failure causes truly catastrophic consequences we can't recover from.